Okay, so let's talk about some of the data that we have here in the paired sample t-test. Okay, we have the mean and the number of participants, 5. We have a standard deviation. We're not going to stress about the error mean because we're not going to report it. Okay, so down here you have the paired sample correlations, and understand something about SPSS. 9 times out of 10, the words that you're going to need to find something are right there. You're going to have to know some abbreviations, okay, along the way, but everything's right there in front of you. Everything in these tests that you're going to do, you shouldn't have to search for other than to search to find where it actually comes up. So you have the number of participants, you have the correlation, okay, and you have the significance, okay. Down here you have the actual paired sample t-test, and you'll see where it says pair 1 caffeine versus no caffeine. Okay, then you have this long line of numbers. Okay, you have the mean, the standard deviation. We're not going to worry about these 3. Okay, then we go to the t-value, the df, and the significance. Okay, so this is the point where I want to talk about significance. We're going to talk a little more in detail next week because it's something that takes a little while to get used to. We deal with a number of 0.05. That is a level of significance. It's given right here in this area that's called sig. It can either be two-tailed or it can just say sig. And when we do we have one test where it comes up and it just says sig. You'll see that it's also here as a sig here, and that is the significance for this correlation. Okay? This right here will answer your hypothesis. This number right here. This t-value, which we will get into when we get into actual one sample t-test and go over it in detail, correlates to this same number here. So this is like a checks and balances. When the formula is run, it gives you a t-value. That t-value then equates to a significance level over here. So we could take this number, the number of df, go to a little chart, draw our little lines out, find the number, but our number is right there. It tells us this number. It also tells us that this is a significant number. Not 0.005, but 0.5. Okay? This is well below it. It's closer to 0 than it is above 5. Okay? This is where you get caught up a lot with numbers. You've got to really look at the numbers and say, is this above or below 0.05? It's real simple. Your significance is either significant or non. If it is above 0.05, it is non-significant. If it's below 0.05, it is significant. Okay? Faster you get that, the faster we move through stuff. Okay? So let's go back to the beginning. In front of you, you should have this test right in front of you. Tell me something about the mean that you can just right off the top of your head see. Let's see, does this work? Right here, these two numbers. What does it tell you? Get more sleep. Perfect. That would be what you're going to be looking for when you get to do your study. That's your first answer. Your first conclusion is right there. It's the easiest one. One's bigger than the other. Now it's why. In this test, we won't know why. Okay? You have a standard deviation, which is very rare. Exactly the same. Okay? When SPSS spits it out, it generally gives anywhere from 4 to 5 numbers. Remember, this is point, in this case, it's 1.14. You will then round that next one up or down based on about that next number. Let's go back to general math and just round the number. Here you've got 5.40. Okay? Over here you have a correlation. Okay? So our first thing is we know that, of course, and we knew from just sight that no people that didn't drink caffeine got more hours of sleep than people with caffeine. Okay? But those with caffeine probably stayed awake longer because they used the caffeine. But that's not part of the test. Pair 1 in a correlation. Okay? Looking at the number line here, where does that fall? Where do you think it falls? Is it positive or negative? Positive, okay? If I was to erase all of this, because we're on the positive side, and redraw that line, and then I was to throw the number of, what is it, 0.38? 0.038. Not a perfect representation, but gives you an idea. What would you think of that correlation? I'm going to stay over here. Maybe you can see it. Right here. What would you think? Very weak. Okay? Very, 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 very weak. Okay? It almost has no correlation. That does not take away from this. Now, why could that number be so low? Anybody want to take a guess?
Small sample size.
Bingo, small sample size. You can have the same problem if you had a huge sample size. Okay, so we have a very small sample size, and that number pops up real low. So this is a slight, or very slight, positive correlation. That's in a nutshell. Okay, it is significant. You don't really talk about the significance. I'm sorry, it's non-significant because it's about 0.05, and it's non-significant. If you have a real number like that, you're generally going to have a non-significance. This non-significance also comes from the idea that you have a low sample size. Yes.
But isn't it below 0.05? So wouldn't it be significant? Oh, this. Sorry. This.
If you go down there, you're right. You're right on the bottom over here at 0.95, almost close to 1. Okay? So we now know we have a very slight, or in this case, you could say very low, very slight. I like slight. Very slight positive correlation. Okay? This portion down here we don't stress about. Now over here, we know that we have a significance. Okay? And we have a DF of 4. Okay? Why do we have a DF of 4? Because it's still here. It's still n minus 1, meaning 5, meaning the n being 5, minus 1, leaving 1 to vary. We have a t-value of negative 5.66, rounded up. Okay? This is what your semester is going to look like. We're going to talk about it. We're going to kind of go through every step of the way. You need to know what, for each of the tests, you need to know why these answers, why you're looking at this answer. What does this answer tell us in a sentence? Okay? Okay? In this case, this is the only time you're going to be, other than looking at regular correlations, this is the only time you're going to use a correlation. Okay? Down here, you're going to be dealing with t-values, DFs, and your significance. Those are the important points that you need to find along the path to be able to write these things up. Are there any questions? Anything you didn't understand? Okay? So I'm going to pop back into the PowerPoint.
What does DF stand for?
Degrees of freedom. Okay, I want to stop that one.